Welcome to EconTalk, part of the Library of Economics and Liberty. I'm your host, Russ Roberts of Stanford University's Hoover Institution. Our website is econtalk.org, where you can subscribe, comment on this podcast, and find links and other information related to today's conversation. You'll also find our archives, where you can listen to every episode we've ever done going back to 2006. Our email address is mail@econtalk.org. We'd love to hear from you. Today is May 21st, 2013, and my guest is Jim Manzi. Jim has thought a lot about what we can learn from experimental data. He is the chairman of Applied Predictive Technologies. He's the author of Uncontrolled, which Jim and I discussed in a podcast in June of 2012, last summer. That's a book about the challenges of teasing out causation in a complex world. And today we're going to go a little deeper than we have in the past, or at least continue to go deeply into the Oregon Medicaid study, a subject of a recent podcast with Austin Fracht. And you might wonder, why are we doing a second podcast, a second episode on this one study? And two reasons. First, I think that over the next year and a half, you're going to be hearing a lot about the Oregon study. I think it's going to play an important role in the continuing conversation about implementing Obamacare. But the real reason I wanted to talk to Jim was because of a fairly lengthy essay he wrote about the study, which we'll put a link up to, that I found to be utterly fascinating in the aftermath of my discussion with Austin Fracht. They both looked at the same study. They both looked at the same results, but they drew very, very different conclusions. More than that, Jim noticed some results in the study that nobody else seems to have noticed, and I thought it'd be fun for you, the listening audience, to hear some of those observations. And along the way, we'll get into some other issues related to data and statistics and what kind of conclusions we can draw. We won't just be talking about the study, but it's a wonderful vehicle for examining some of these questions. So, Jim, welcome back to EconTalk.
Thanks for having me back.
First, a quick review of the experiment. Oregon decided, and you can correct me if I'm getting these facts wrong, Jim. Oregon decided to expand their Medicaid program, which is a health insurance program for poor people, but they didn't have room for everyone who was conceivably eligible for this expansion. So they had a lottery, and that created two groups: people who won the lottery and ended up on Medicaid, they were the experimental group, and people who were somewhat similar but who just happened to lose the lottery. So it was a chance to do a controlled experiment, which you don't get to do very often in economics. And so Oregon used a bunch of first-class health economists to follow up and study what happened to these folks both before and after the enrollment into Medicaid for the experimental group and for the control group, to just examine what had happened to them in the meanwhile. And this recent study that came out in the New England Journal of Medicine was a 2-year was a little after 2 years. I think it was 25 months. So 2 years after the study had started, they wanted to see what the effect on the experimental group was. And now I'm going to read a very short summary. This is from the conclusion in the New England Journal of Medicine paper. Quote, "This randomized controlled study showed that Medicaid coverage generated no significant improvements in measured physical health outcomes in the first 2 years, but it did increase use of healthcare services, raise rates of diabetes detection and management, lower rates of depression, and reduce financial strain." So there were no significant improvements, and we'll be talking about what that means, significant. No significant improvements in measured physical health outcomes. That would include cholesterol, blood pressure, and I think blood sugar levels. And most of the debate over the findings has been on the physical health measures, that there was no significant improvement. But there were some improvements. They just weren't statistically significant. We'll come back to that. But as when we had the conversation with Austin Fracht, we looked at those range of findings that were in that summary. But what fascinated me about your analysis was that was not what you started off with. You started off by noticing something that no one else had noticed, that not everyone who won the lottery chose to apply for the opportunity to get what was essentially very, very inexpensive and sometimes free healthcare. Explained what happened there and what you learned from it.
Well, to start with what happened, your summary, to my knowledge, is accurate. And there were just under 90,000, 89,000 some people who signed up to participate in the lottery. of those 89,000 or roughly 90,000 people who signed up for the lottery, 35,000 roughly were selected. That is, they won the lottery. Selection actually happened at the household level, so it was really about 29,000 or 30,000 households are selected. But since the measurements for physical health are happening at level of people, in general, we talk about people in the study, even though technically selection happened by household. So about 90,000 people applied. 35,000 won the lottery. And what winning the lottery meant is if you submitted an application within 45 days and were found to be eligible, you were granted access to this Medicaid program. So of the 35,000 people who won the lottery, about 60% filled in and submitted the application within the deadline. Therefore, obviously, 40% did not. Of those 60% who submitted the application, about half were eligible and about half were not found to be eligible, either because their income was above the poverty level or some other reason, but that was the primary reason according to the authors of the study. So one simple observation that I had is that it was surprising to me that not that you didn't have 100% of people who won the lottery fill out the application and submit it, but that almost half of the people who won it didn't. And I think if your mental image of the uninsured, and I put this in the piece, is a family huddled outside a hospital with a sick child who just cannot get the money to pay for the doctor to give them antibiotics, that result doesn't make a lot of sense. And I also don't want to trivialize the extreme difficulty that high levels of poverty can create in accomplishing seemingly straightforward tasks. I understand that there are huge challenges in accomplishing something like that. When you're moving a lot, you're often not opening all your mail because it's mostly bills. You have a lot of problems being able to get things done. But I do think that just by the iron laws of logic, there are only one of two possibilities for why someone, a given winner, did not submit that. Either a rational analysis indicated that the expected gain from coverage being offered didn't justify the time and effort of filling out the form and submitting it, or the winners did not act rationally about the long-term benefits versus immediate inconvenience. And to me, I think neither is a strong argument for the value of this program, because if it's the first case, it just means the insurance isn't really worth a lot to those people, at least those 40% who did not submit it. In the second case, I think it indicates that the same things that make it hard to submit the application to get the insurance are probably indicators that conformance with the kind of therapeutic regimens that are necessary to affect the key physical health indicators, which were measured in the study, which are basically blood pressure, blood sugar, and cholesterol, are very likely to slip and not be met. And so that to me was a very telling fact that I hadn't seen anyone mention. Subsequent to doing this, I realized that Avik Roy also pointed out the same thing.
Who pointed it out?
Avik Roy, who's a healthcare blogger and analyst. But
just to untangle that last that closing point, which I think may have been lost in some healthcare jargon, what you're saying is if you're not very excited about being part of Medicaid, maybe you won't be so good at complying with whatever health rules or drugs that might purport to help you. You might not be a regular taker of your meds. That's what you're worried about.
I think that's right. I mean, either you're not excited about it because, in fact, it really isn't worth that much. I think the much more likely case, intuitively, the much more likely case is, in fact, you do at a rational level at least see getting health insurance as being quite valuable. But the fact that you did not submit the form within 45 days is a marker for your likely behavior over the 2-year coverage period that's being studied here, that, as you say, indicates that for various reasons that I can understand, given the kind of life situation you might be in, you don't take your meds every week, or you have a dietary exercise regime you're not following, or you are not doing any of the many things that are necessary to manage a chronic condition to drive the specific health improvement in the specific health indicators that are looked at here.
And just to clarify this, if you were selected in the lottery and you were eligible, again, correct me if I'm wrong, but I think it entitled you to all forms of standard medical care, including pharmaceuticals, other than, I think Austin Frack said, dental and I think eyeglasses, but basically all basic medical care services would be available to you, and you'd only have to pay a monthly fee as a participant in the program of between $0 and $20, where the amount you'd pay depended on how close you were to the poverty line. So I assume if you were at the poverty line, you paid $20 a month, but if you were at something below the poverty line, you might be paying as little as $5 or $10 a month, or maybe $0 if you were very poor. And so this was a deal on the surface. This was an incredible bargain that, as you say, 40% of the folks decided it wasn't worth it or just missed the chance. As you said, we don't really, as you point out, we don't know what the real reason was. And it would be a very interesting follow-up, I think, to talk to those 40% because it's not a small number. It's not like, oh, they were this odd group that just for some reason passed up a chance for free healthcare insurance or cheap healthcare insurance, nearly free healthcare. They just, a massive group, 40% said, I'm not going to do it.
That's right. And I think that some of the possible reasons beyond literally just saying, well, I'm not going to bother, are they were moving frequently. So it's actually hard to contact them by mail. Another reason is they could have, for one reason or another, moved onto some eligibility for some other insurance. I think the authors think that second cause would be a relatively small number. But there are also virtually certainly some of them who, in fact, the mail did arrive at the house where they lived, and for whatever reason, they didn't submit it. And I really went to great pains to say I wasn't trying to make some kind of a judgment, a moral judgment. This isn't about a moral judgment about these people who didn't respond. It is purely about a marker for behavior, which, in my view, is intuitively correlated with plausible failure to comply with chronic disease management regimen.
So how does that affect, and this is where I think it gets very interesting as a general example of how to think about data and findings and studies, because this is, quote, the gold standard. It's a randomized controlled test. It's one group that just happened not to win, another group that did win, and we're going to compare them. But as you point out, the fact that 40% of the one piece of the population did not submit may affect the reliability of the results. Explain.
Well, I think that the reason that a randomized trial is the gold standard, and I go to great length in this in Uncontrolled, and it will be old news to many of your listeners, but the reason that a randomized trial is the gold standard is that we want to try and identify the causal effect of the treatment, in this case, access to insurance, that is being offered in isolation of all other factors. And of course, economists and analysts of various kinds attempt to hold all factors equal between two groups, one of which got a treatment and one which did not, through various mathematical methods, regression and matching and other things, which attempt to say, well, I can see what tends to create different outcomes in the outcome metric of interest and make sure that the people I'm looking at with the treatment are matched up against people who are alike in all material respects as a control group. And the problem, of course, is we can have unobserved variance. In other words, there may be differences in the people who are in a treatment group versus a control group that we just don't have data on or can't model. And therefore, we cannot be as certain that we have equivalent groups in the test group and the control group other than the treatment of interest. If we randomly select individuals into the test group versus the control group, and we'll get into this, I'm sure, in detail, subject to sampling error, I know that even if there are factors which I haven't thought of, I should have them approximately equally distributed in the test group and the control group. So therefore, when you come to an experiment, there's a question which is, well, at the point of randomization, at the point of random assignment, I know that assumption is true subject to sampling error. That is, at the moment in which I ran the lottery and I said, you win the lottery, you lose the lottery, I have two groups who should be alike in all material respects subject to sampling error. As soon as I start to take subgroups of the group that won, I immediately find myself back in the same problem of, well, how do I know the subgroup, which is the 60% who submitted the application, and of those, the ones who were eligible, how do I know which of the people who lost the lottery are most like them, and how do I know how similar they are? And running the analysis such that you simply compare the group that won the lottery and compare their outcomes to the group that lost the lottery is called the intention to treat or intent to treat principle. And that is, if you're being strict about only using a gold standard randomized trial, that's how you measure it. Now, what the authors are interested in is what is the effect not of winning a lottery, but what is the effect of being granted Medicaid? And I talk about this exact issue at length in Uncontrolled when talking about lotteries for school vouchers. And what I say is, it's the bacillus of econometrics is introduced because you have to basically do some kind of modeling to say, I'm going to look at the characteristics of those individuals who are the subset of those who won the lottery, who actually got the treatment that I'm interested in, and compare it to some subset or some adjusted benchmark for those who lost. And it means that you lose some of the reliability that you would have if you measure on an intent to treat basis.
Now, in this particular case, I'm going to use the word prudence, which I like because it's an Adam Smith word. Mm-hmm. Adam Smith talks about the virtue of prudence, that you look out for your own well-being, that you're not reckless. So if I understood what you wrote correctly in your essay, it's possible that the people who chose to apply were more prudent than the ones who didn't apply. And therefore, when you look at the control group, which does not select out for prudence, it has a mix of prudent and imprudent people, you are attributing some of the whatever effects there are of the Medicaid study, some of that may be due to prudence rather than just Medicaid. Is that an accurate way to say it?
Yes. And I think that if you look at all the treatments that are reported in the headline results, they are the treatments that are estimated for the effect of being on Medicaid. If you were to instead say, I want to measure the treatments such that I want to measure what's the causal effect of winning the lottery versus losing the lottery, you can essentially take any of the estimated effects in the headline results in the paper and divide by 4. It's about 24 or 25% of the effect, which you would expect because only a small subset, only something like 30% or so of those who won the lottery got the treatment. And one of the things I argue in my book is that, and this is consistent with how a medical trial is classically run. I mean, this is consistent with the first known randomized clinical drug trial, which is the pertussis vaccine trials in Norfolk, Virginia in the 1930s. You measure effect at intent to treat. You apply the principle of intent to treat because one is so concerned about this problem of how do I know that some subset of the test group is really comparable to some subset of the control group? And really all the arguments in that essay simply become a lot stronger that I made in the essay, become a lot stronger if I just take all the effects and divide by 4, which is what you would do on an intent to treat basis.
Explain that. What do you mean I divide by 4?
Well, one way to look at this is say I have 35,000 people who won the lottery and I have 90 minus 35,000 people who lost the lottery. And what I'm going to do is I'm going to measure blood pressure for all the people who won the lottery and all the people who lost the lottery. And I'm going to look at the change in blood pressure for those who won the lottery versus those who lost the lottery. And I can ascribe the change in blood pressure, by this example, to the causal effect of winning the lottery. Our intuitive belief is the mechanism by which winning the lottery is improving or not blood pressure is that a subset of those who won the lottery were given this Medicaid, access to Medicaid, which is quote unquote the treatment. Being able to say, oh, but I know that there is all of this effect is due to for the subset of people who won is due to being given the Medicaid treatment is a less reliable conclusion. And so the strictest way to look at this, and the authors were great. I mean, in the supplementary appendix, unlike many of these papers, they went through the details of what the intent to treat effects were. If you do the analysis on an intent to treat basis, the strictest way to look at this is to simply say the treatment I know I've randomized against is winning the lottery. And so the statement I can make with confidence, it's scientific gold standard. It doesn't mean absolute philosophical certainty, but the statement I can make with high confidence is the causal effect of winning the lottery is X. And it is intuitively going to be much lower per person, given that intuitively we believe at least a large portion of the reason why those some subset of the winners versus some subset of the losers will have improvement is because only some subset got access to Medicaid.
So another way to say it is that there's this group of people who didn't win the lottery, who won the lottery, didn't apply, and we're going to presume that they didn't have any effect because they didn't get the treatment. Is that correct?
That is the basic assumption that is made rather than doing an intent to treat analysis, you do an analysis which tries to evaluate the effect of winning the lottery and getting coverage. But what the problem with doing that is what we don't know is what we just talked about is there some unobserved bias in those among the winners of the lottery for those who actually achieved Medicaid coverage versus those who did not. So in other words, to go back to what we were talking about a second ago from the essay, if I assume for the hypothetical purposes for this discussion for the moment, that effectively those out of the lottery winners, those who went through the process of getting themselves registered are different in terms of their prudence, in terms of their behavior over time than those who won the lottery but failed to do that.
Self-discipline, all kinds of unobservable measures.
I talk about this conscientiousness plus, that kind of rigor. If that's true, and I'm comparing now a subset of people who won the lottery who are prudent and looking at their change in health outcomes to a group of other people who are a mix of prudent and imprudent, I am going to misascribe relative improvements in the prudent subset of the prudent subset of the lottery winners to the effect of Medicaid coverage, when in fact it's the effect of this prudence mixed with the effect of Medicaid coverage.
So when you say divide by 4, you're saying let's make this is sort of a lower bound, because we're going to assume that the people who didn't win the lottery would have been very imprudent and wouldn't have taken any of the medication and therefore wouldn't have had any effect equivalent to the control group.
No, in the supplementary, that's conceptually correct, but it is also the case, and where the number I gave you came from is in the supplementary appendix to the paper, the authors report the results of doing exactly the analysis I described, which is I take the whole group of lottery winners and compare them to the whole group of lottery losers. They actually report all the statistics on it. Because
they have the data on the lottery winners, even though they didn't get the treatment?
As far as I know.
Okay. That's totally different. I misunderstood that. Okay, so that's very cool. But let me go back the other way. Let me argue that the experiment understates the effect of Medicaid, because not everybody has high blood pressure. So why would I expect, since high blood pressure is only a particular portion of the population, I wouldn't expect most of the people to benefit from that. So as I add people, if I increase the size of the study, a lot of these people aren't going to have high blood pressure. So should I include those? Are they included?
Well, you could think of it as there's just a treatment. The treatment is anything. It's any change in the environment created for a test group, a treatment group, or a test group versus a control group. And the treatment in this case is I have a group of 10,000 or so people, and they now have access to Medicaid, and I compare them to a quote-unquote a like group who do not have access to Medicaid. And the causal pachinko machine of how access to Medicaid is going to play through to my blood pressure being different, my blood sugar being different, my cholesterol being different is extremely complicated. For some subset of people, they're going to have Medicaid coverage and they're just not going to go to the doctor. Other people will go to the doctor and they'll be diagnosed with some disease state that results in some clinical treatment, like you're now going to get this drug. And some of those people will take the drug and some won't. Some will be misdiagnosed. Some will have no clinical state relevant to blood pressure and be given medicine for something else, which will have, an iatrogenic effect, such that I'm going to, it's going to raise my blood pressure and make it worse. What we're doing is not trying to peel apart all those sub-effects here and simply asking the most basic, what's called in business an A-B split. You get the treatment, you don't get the treatment. Just measure the outcome difference for those who got the treatment versus those who didn't. Where the treatment is not a clinical treatment here. The treatment here is Medicaid coverage.
Medicaid coverage. So let's go to the basics now. Were you surprised that there was no improvement? There were a lot of people who expected this to have wonderful effects. Maybe not on mortality, which is hard to measure in 2 years, but certainly on things that are thought to be related to mortality. We mentioned in recent podcasts with Eric Topol and Austin Pratt that having a lower cholesterol score actually might not have that big an impact on your mortality. But we're putting that to the side. Are you surprised that having access to Medicaid did not significantly improve the physical health characteristics of the people who won the lottery, who were enrolled in the program?
It didn't surprise me. Two huge caveats are: one, I'm so not expert in the subject that my surprise or lack of surprise does not have a lot of information content. And the second caveat is the only reason it didn't surprise me is out of interest in the methodology. I looked at the only prior randomized study which looked at the effect of varying levels of health insurance coverage, which is the RAND study from about 30 years ago,
right,
which showed no effect. It really surprised me when I looked at the RAND study that it showed no effect. So prior to having seen the one prior randomized experiment, it was shocking to me, actually. But because that was essentially established my prior, no, it didn't.
And the RAND study, it showed no effect on healthcare outcomes. It showed, like this study, an increase in healthcare usage, but not, tragically, not an increase in healthcare outcomes.
That's correct.
Now, Austin Fracht, when he was on the program a couple weeks ago, he said, well, it's not surprising, it's not significant because these the experiment was underpowered. Now, underpowered is a technical term in statistics. Explain what he meant by that and whether you agree with him.
Well, let's see. Power in a statistical experiment is, and I often use this analogy, is sort of like the magnification power on the microscope you probably used in high school biology. And, you know, it has on the side 4x, 8x, 16x, which is how many times it can increase the apparent size of a physical object. And the metaphor I'd use is if I try and use a child's microscope to carefully observe a section of a leaf, looking for an insect that's a little smaller than an ant, and I don't observe the ant, I can reliably say, I don't see the insect, and therefore there is no bug there. If I use that exact same microscope to try and find on that exact same piece of leaf, not a bug, but a tiny microbe that's, you know, smaller than a speck of dust, I'll look at it and I'll say, I don't know, it's all kind of fuzzy. I see a lot of squiggly things. I think that little squiggle might be something or might not. I don't see the microbe, but I can't reliably say that therefore there's no microbe there, because as I try to zoom in closer and closer to look for something that's small, all I see is a bunch of fuzz. So my failure to see the microbe is a statement about the precision of my instrument, not about whether there's really a microbe on the leaf. And I think the argument that Austin Fracht has made around this is this experiment, because of basically the sample size, the number of people in it with different disease states, is an instrument which is sized so that it does not have sufficient precision to find the size of clinical effect a rational and informed observer would expect there to be on these healthcare outcomes.
So to summarize, and I know you're going to challenge this maybe in a minute, but to summarize what the fans of the study and fans of Medicaid and fans of health insurance have argued is that, well, there was a lot of positive effects on cholesterol and on blood sugar and on blood pressure, but they weren't large enough to be distinguished from random effects. But that's just because the sample wasn't big enough. The alternative view is that, well, the effects weren't very large. If the effects had been large enough, then even a small sample would have identified them. But Austin Fracht has argued that, well, no, even if it was a big sample, would have required huge effects. I don't know if you looked at his calculations or not, but
I did. So, I mean, I think we have to be careful about what we mean by large effects. So there is what some people have called clinically large or clinically significant, like I care about this outcome, it's that big a deal. Or alternatively, and I think this is the second of these senses, is the sense in which Austin Fracht has made the argument, is if I think about what a rational, informed observer, that is someone who knows about what we would expect given the package of treatments that would be applied against this population and the starting disease state of the population and how we know medicine works, would the expected effect we think we would normally see by applying this treatment called Medicaid coverage be large enough to be detectable by this experiment? And so, you know, I think a simple way and a straightforward way, and I don't want to restate his argument for him, and it's Kevin Drum's made the same argument, but I think I'm being fair about this, is, look, and I think this point of view is internally logically consistent and an intelligent point of view, which is basically, look, your experiment is designed, its sample size means it can read an effect of size X. When you look at what you would expect the clinical effects of the benefits being accorded through Medicaid coverage to be for this population, it's like 1/20th of X is the change in improvement in health you would expect to see. So the fact that when you use this child's microscope to look for a microbe, an experiment that can find the size X, and it didn't find any statistically significant effect when really we would expect it to be like a 20th of X, well, you got no new information from this study. Sure, of course it showed you no statistically significant effect, because you'd have to get, you know, a gigantic multiple of what, you know, biology and clinical experience should say we should get from applying Medicaid. I mean, I think that's the basic argument.
That's their argument. Do you agree with it?
And well, so I think that Austin Rack I listened to your podcast because I know I was going to do this podcast, and he comes across to me there, as does Kevin Drum, and as he does in his writings, as a smart, informed, and reasonable guy.
And by the way, just to interrupt for a sec, I'm going to invite Austin to write a response to this podcast, which I will post as, I hope, an early comment on the EconTalk page, as well as on EconTalk's Facebook page, which is now available for liking. So please check that out. So carry on. Sorry about that,
Great.
Jim.
So, I mean, I think the whole issue then is calculating these numbers, going from this conceptual argument of, you can measure at size X and the effect should be, say 1/20th of X, to actually calculating the two numbers. One is what's often described as the power of the experiment is X, and the expected effect is this other number, which the argument is smaller. So, when it comes to calculating the power of an experiment, which is basically saying how small an effect can it measure reliably, I know how to do a power calculation, but I don't know how to do a power calculation for somebody else's very complicated experiment without access to the underlying data and their analytic methods. Second, when it comes to saying, well, when applying Medicaid to this population, what change would you expect in, for example, blood pressure? I don't begin to know how to do that. So, I don't know how to calculate these two numbers. The only case in which that I'm aware of in which the authors of the study have made any statement about these two numbers is the case of diastolic blood pressure. So, and this is actually on Austin's blog. So the lead author of the study, in response to essentially this argument, in correspondence said, well, take diastolic blood pressure as an example. And so diastolic blood pressure is the second or lower of the two numbers in your blood pressure reading. So if you're 110/70, it's the 70. And what she said in this first number, you can take right out of the study, which again, if you accept the analytical premises, which you talked about before in the study, the author of the study says, well, we can read an effect of a reduction in diastolic blood pressure of around 2.65 points. And for some technical reasons, if you look at a subgroup that might be relevant, it's a little more than 3 points. So essentially, in rough terms, the author of the study asserts the power of this experiment for reductions in diastolic blood pressure is about 3 points. So in other words, the average person, I think, had about a 76 blood pressure reading who was in the study. So they could read, if the average went from 76 to 73 in test versus control, they would be able to say, that's a real effect we can measure and call that statistically significant. So then the question is, well, I don't know, would you expect this kind of coverage as an informed observer? Would it be like a 20th of that, which is a small fraction of 1 point, or would it be, 10 times that or around that? And her assertion is, look, the benchmarks for what a reasonable expectation of the effect of this coverage are two, one of which is the RAND study, which measured an effect of a 3-point reduction in diastolic blood pressure. And the second is another study which measured a reduction of 6 to 9 points. So, I mean, if I take 6 to 9 is, 7.5, average is 7.5, the average of 3 and 7.5 is 5.25, right?
Yeah.
In other words, in this case, for diastolic blood pressure, according to the author of the study, it's not X and 20X, it's, X and more than X. You can measure it down to 3. The precision of the microscope can go down to a measurement of size of 3. The effect they would expect is 5.
So I got lost there. So they expected, from past studies, you might have expected, given the opportunity to be on Medicaid for 2 years, might lower your blood pressure your diastolic blood pressure by 5 points.
Right.
Not percent. 5 points.
5 points,
from 76 to 71.
71 in concept, yes.
And they found a decrease to 73.
No, if they said the precision of their instrument is a 3-point reduction would be measured as a statistically significant reduction in blood pressure. So in other words,
so there was sufficient power to measure what they could have found 3 that they excuse me. The study was sufficiently powered, meaning the sample was large enough that if it fell by 3 points, it would have been statistically significant. It could have been, and certainly 5, right? Which is the 5.25 or so, which is the sort of average of 2 past studies.
Right.
Although I presume one of them wasn't statistically significant either, which is the RAND one. You said it was 5 points, but if I remember correctly, didn't find
3 points.
What?
It was 3 points. The other study was 6 to 9 points.
Oh, sorry. Rand was 3. Okay. So that sounds like they're saying, the author was saying, that their study had sufficient power to measure what could have been expected reasonably from the effect of the treatment. Is that correct?
That's correct. That's correct.
What did they actually find?
Measured about a little less than a 1 point reduction, so a negative 0.81 point reduction. Okay.
So that brings me to my next point, which I think is a very important general point that is lost in 99% of these kind of discussions.
So let me just make a quick comment about the argument I just made, which is I don't have any idea whether, other than this, the person who's the author of the study presumably has studied this in detail, and the things I know about in this study are extremely well done. So I'm assuming, without knowing, that is the valid way to create the clinical benchmark, like is 5 a reasonable number to expect. And I'm also assuming that because she provided this as an example, it's not the case if you looked at 15 metrics. She picked one metric where they had power and not the 14 where they didn't. So I don't know about that. And I think the project Austin's undertaken, which is figuring out what the power of this experiment is and trying to create these prior benchmarks, i.e. what would be reasonable expectation against these different clinical effects, I can't possibly, comment on it. I just don't have the expertise to comment on it. All I'll say is in the one case where the study authors have commented on this, they're claiming it has power.
So, Megan McArdle ran your essay at the Daily Beast, and I don't know if it's run anywhere else. I don't know if it's posted anywhere else. But Megan made the point that the authors of the study were probably aware of this. So it'll be interesting about this issue of power. Obviously, when they designed the study, they had some expectation of what sample size would be necessary to measure independent effects of the experimental treatment. And they didn't go into this blind. And they didn't write a survey or a study that said, of course, we're not going to be able to measure this with any precision. But we'll let Austin respond to that.
Well, I think that a point there, though, is that they didn't design the study, right? It was a lottery run by the state government. They didn't set the sample size. So I could easily see, I'm not saying this is the case, but I could see an argument that says, look, I mean, we're dealt a hand of cards. We did the analysis on it. There was no reason to do a power calculation in advance because we didn't control how many people were on it. We were just trying to learn what we could out of this. So I do not make the assumption that they did prior power calculations and knew this was correctly powered.
Good point. Fair enough.
I don't know.
Fair enough. But here's the punchline. And for those who are tired of hearing about Oregon and Medicaid, I think this is an incredibly important point. We have one more coming for those who are lost in the weeds. There's an incredible punchline coming in a minute from Jim's analysis of the survey, which blew me away. But I want to make this point first. In the social science literature, I'm sure in other literatures, but overwhelmingly in the social science literature, certainly in the epidemiological literature, everybody is obsessed with statistical significance, which means there was an effect that could be attributed to the treatment or to the causal variable we're looking at, independent of chance. That there's, and the gold standard is 95%. That if we find a result, if we find a difference between the control group and the experimental group that is statistically significant, what that means is typically that there's a 95% chance that this is not due to randomness, but it's in fact due to the treatment itself. Correct?
Technically, the p-value or the 1 minus 95% or 0.05 is the probability that an observation as extreme as that data would occur by chance, given that the true effect was 0.
Given that the true effect was 0. Thanks for that. Right. Yeah, correct. But what that obsession misses the probably much more important point, which is the magnitude of the effect. The fact that it's statistically significant is often not nearly as important as to whether the effect is large. So just to take an obvious example, expanding Medicaid coverage, which is part of the Affordable Care Act, known as Obamacare, it's expensive. It costs a lot of money. So you care about not just whether it changes people's blood pressure and cholesterol level and mortality. You care about whether it changes it significantly, not in the statistical sense of significantly, but in the everyday sense, meaning a lot. And unfortunately, the phrase statistical significance it's a misleading term. Not deliberately misleading, but for non-technical people, it makes you think it's significant, meaning important. all it means is that it's not due to chance. If the effect is small, then the effect could be statistically significant, but policy-wise insignificant. And so this last example is a perfect example. Let's pretend they had found that, in fact, the reduction in blood pressure was statistically significant. Wow, Medicare coverage has an effect on blood pressure. But if it's less than a point in reducing your blood pressure, it's insignificant in the real sense of the word. Agree or disagree?
The general point of these, there are two different meanings of the word significant, and it is misleading when you use it in the technical sense in a lot of dialogue where people assume the common sense meaning of the term. I definitely agree with. I wouldn't jump to the conclusion that a 1 point reduction in average blood pressure is not clinically significant, just because it could be that what you have is 99% of people are at 75, and you have 1% of people at 140. And the way you got the 1 point reduction was take that 1% of people and bring them down substantially.
Yeah,
and
that's my earlier point.
Risk that way.
That's my earlier point, right? This is your point was that this is for the whole population. So it's mixing in people who you wouldn't expect to have an effect. Is that right?
Yeah, that's right. So in other words, you can get to a 1 point average by a small subpopulation with a significant move, and that could result in a material reduction in total mortality for the group. Because one of the points I make in the essay is, if you just think about the numbers, right? If you use, and I don't want to get into the debate about how many people are insured or uninsured in the United States, but if you use a conventional number like 50 million people who are uninsured, and you say a reduction in probability of 10-year mortality of 0.0001, that's 5,000 people. Right. So until we start to trade off against costs and closing off other reform options, it's basically any change in mortality probability is going to be morally significant. You're going to have to then get to the issues that you're pointing to, I think, which is, okay, but there's no free lunch.
Yeah. So
what am I giving up to get that?
So let me correct what I said. Let me say it a little more elegantly then. When you look at it's policy significance rather than instead of statistical significance. If you want to see whether a result is important, you have to look at its magnitude. Your footnote to what I said is that, but sometimes something that looks like a small number is actually larger than you think, because for some people, I take that point totally. Agreed. Yeah. Okay, let's move on. Let's move on to what I think is the probably the most interesting thing in your essay. All these things were interesting, but the most interesting was related to what is known as the Framingham Risk Score, which is related to a longitudinal survey, correct? It's called the Framingham Study, that looked at a large group of people over time and tried to measure their chance of a heart attack. Is that correct?
It's cardiovascular disease, so it's not just MI. It's a variety of indicators of negative outcomes, cardiovascular outcomes. And
how is that risk score? What's it composed of?
In this study, there are different versions of it, and I am not an expert on building up Framingham risk scores. But in this study, the variables that are used are age, cholesterol levels, blood pressure, blood sugar, whether or not you're using medication for high blood pressure, and smoking. So effectively, there's a formula which combines those various factors for any person, and from that computes a scalar number, which is your Framingham risk score.
And that score for the experimental group went up, correct?
For the experimental group as a whole versus the test group, it went down very slightly. For those in the test group who started sick, who started with an elevated risk because they had diabetes or hypertension or high cholesterol, et cetera, for that group, it went up. For the overall population of the test group versus the control group, it went down extremely slightly.
For the group that went up, though, for either of those, it was not statistically significant again.
That's right. That's correct.
However, you made the point, which the observation, which was hidden away in Table 5. I paid for the study, by the way, so I won't be able to – I'm now talking about the summary of the results from the New England Journal of Medicine. So if you want to pay, I think it's $15, you can get it. But we may be able to put up Table 5 or some piece of it. I'll find out. But in Table 5, you noticed something rather extraordinary about the test group, which was?
Well, estimated effect of coverage, which was statistically insignificant, was an increase in the incidence of smoking in the test group versus the control group. In the control group, it was about 43% of people who smoked, and the causal effect, as indicated by the study, was a 5% increase to 48% smoking in the test group, which was not a statistically significant result. So you would, under conventional standards, which I support, you would not ascribe that as a causal effect. You could not reject the hypothesis as random chance. Although interestingly,
it is close.
Exactly. I mean, the p-score, the p-value is closer on that than essentially everything else we've been talking about so far in the study.
Yeah, if I remember, I think it was 0.18, meaning there's still some chance there's a good chance. Well, good is it's a bad word. There's an 80% chance that this was just due to random variation. Correct? Is that the correct? Did I say that right?
It's the other way around. So there's an 18% probability that an observation that extreme could occur by random chance if there were in fact no causal effect of Medicaid coverage on the probability of smoking. Say
it again one more time. Maybe you should use 80. Go ahead, try again.
I think the strict way to say it is there's an 18% chance that an observation that extreme or more extreme in terms of the difference in the test and the control group would occur by random chance, given that the null hypothesis is correct. That is, that the true absolute causal effect of Medicaid coverage on smoking is nothing.
So if the p-value had been 0.03, we would, right, it's the other way around. So if it had been 0.03, we would have concluded that it's very unlikely it was due to chance.
That's correct.
Right. So 18 says it's an 18% chance it was due to chance, but and of course it's an arbitrary measure. 0.05 has become the cutoff for what is by chance or not. So in this case, like all the other results, we would conclude that we can't reject the hypothesis that this is just random. We can't attribute it to being on Medicaid. But you discussed the possibility that it might be attributable to Medicaid. And what was your argument?
Well, without respect to this, without pinning it on this finding, I think there is a well-known effect that's often called the seatbelt speeding effect, which is
it's called the Peltzman effect. Which is because he was the economist who found the seatbelt effect. Go ahead.
So the basic idea of it is, if I reduce the cost of a risky behavior, I will on net induce the incidence of that risky behavior, because the thing that I've changed is the cost of the bad outcome is not quite as bad as it used to be. And so I think the application here is, if you reduce the cost in the broad sense, not just the monetary sense, to me, of the negative outcomes of smoking, even though smoking on balance is still bad for me, it is less bad than it was the moment before I reduced the cost effects to me of having negative health outcomes. And there is literature that shows in non-experimental settings, and I make the point in the piece that I don't put a lot of stock in non-experimental findings about this, but there is a literature that says, in fact, you do see an increase in risky behavior if and when you grant additional medical coverage.
Yeah, so I'm skeptical about that. It's fun, and I'm a fan of the Peltzman effect, which is again, for jargon fans, it's an example of moral hazard. You've made it cheaper to take risk, and so you expect people to take more risk. It's a little hard to believe that people would start smoking knowing that they could get, say, treatment for lung cancer in 30 years. So before this, they said, it's too risky. And now they're thinking, or subconsciously, it doesn't have to be literally making a conscious, rational decision, but now they feel a little more secure, so they start smoking. I found that a little bit.
I think it's extraordinarily unlikely that would happen. I think if I were to tell the story of how might this happen, it would be much more likely I would delay quitting.
Yeah, that's a good point.
People who are already smoking who decide, as to your point, consciously or not, delayed the decision to quit, or gave up on, many people who quit smoking have, 6, 7, 10, 12, 15 attempts.
Yep.
Gave up on a couple more of those attempts and got to the 8th attempt before they succeeded, as opposed to succeeding on the 6th attempt.
Yeah, Mark Twain.
I do not know any of that's true. I'm simply saying that would be the more plausible reason, I would think.
Mark Twain said it's easy to quit smoking. I've done it a score of times.
Exactly.
But the more interesting case, which I don't know if you mentioned, to me it seemed the more likely case is financial, that because the experiment reduced financial stress on people. Experimental treatment reduced financial stress because you had this now inexpensive source of health care. Once you're covered, you have more money to spend on lots of things, one of which would be cigarettes.
Yeah, could very well be. I did not say that only because I never thought of it. But, again, I'm not asserting that I know that to be the effect you described to be true, but it certainly sounds plausible as an explanation if you saw an effect like this.
The other thing that was striking, and I think you did mention this, is the proportions themselves, the level. It's a very high rate of smoking relative
it is.
to the...
Basically, that's right. The rate of smoking in this time period a few years ago of basically 19 to 54-year-olds in the United States was a little under 25%. By the research that I did. And so you're really talking about a group of people who, are smoking at, roughly speaking, around twice the rate you would expect for people of their age in that time period. And, the obvious observation is, smoking is an incredible class marker in the United States.
Yeah.
I've been living in France for the last several years, and it's one of the things that's so striking about the incidence of smoking by someone like me, or I suspect you, if you went to Paris and walked around, there's a higher incidence of smoking, but it also seems dramatically higher in relative terms than it really is because it is so much it's less class defined.
Right.
In France than it is in the United States.
Right. I don't know if I know anyone who smokes. Right. Except again, the person who worked on the drywall of my house in a bathroom renovation a few months ago. Do you want to say anything about the depression findings? I did a little looking into that. Did you look into that at all?
Not seriously. I only read other people who talked about it, and I think the two big issues I would think, and one of the reasons I didn't write about it is this thing was already really long, but also I didn't do the work to be confident about an understanding of it. But I believe that a key issue to remember when you see this statistically significant reduction in measured depression is it apparently all occurred within the first month of the study. You could see it immediately. So it makes it much less plausible that this is an effect of actual treatment and the application of drugs and various other kinds of treatments. And it is more like what you would think of normally as a placebo effect. I'm not saying it's true. It's just that given that I have read by the third parties that this happened that quickly, it certainly raises that question. The second issue, of course, is, as always with most psychological conditions, construct validity. So the thing we measured by asking people questions on this form changed. What does that mean about what people normally mean when they intuitively describe mental state and depression and so on? To me is probably a very tricky question to answer.
Yeah, I went and looked at the survey that they used to measure depression. It's basically, I'll just pull it up here. It's 8 questions. I just thought this was fascinating. It's 8 questions. I'll read them very quickly. When you answer the questions on the form, you answer whether this occurred not at all, for several days, more than half the days, or nearly every day over the last 2 weeks. And there are things like little interest or pleasure in doing things, feeling down, depressed or hopeless, trouble falling or staying asleep or sleeping too much, feeling tired or having little energy, poor appetite or overeating, feeling bad about yourself, trouble concentrating, moving or speaking slowly that other people notice. And, of course, many of those characteristics we all have lots of times. And the question is, what's it mean to get 10 points on those questions? And, again, that's, as you point out, it's what you call a construct validity. It's an interesting issue. But the people who were in the treatment group did have a reduction, and that is at least one, and it was statistically significant. So that's at least something positive we can say about the survey, so about the experiment. So first of all, we're almost out of time. I want to thank you, and I hope the listeners heard how careful you were to make claims, and I believe that is the right way to avoid confirmation bias, or at least maybe the right way to say it is that you seem to be fairly good at avoiding confirmation bias, and you were very careful many times in this conversation to hedge what you knew versus what you thought you knew versus what might be true versus et cetera. So I want to salute that, because I think that's wonderful. But where do you think we are now? Did we learn anything from this that we didn't know? What are its implications, if anything, for public policy? And then the other question I would ask, given your background, is there an experiment that you'd like to design or that you could imagine that would do better than this in helping us move forward in the healthcare area?
Well, I guess to take those questions in order, on the first of them, I think that according to the estimates provided by the author of the study, we did learn something about the failure to move diastolic blood pressure, and I think by implication, although I don't know that, other indicators as well. I think it confirms rather than contradicts the results of the one prior randomized experiment, which is that over something like this kind of a measurement period, it's very difficult to see changes in these statistically significant changes in these physical health indicators. I don't think that means Medicaid's a bad idea or the ACA is a bad law or anything like that. I don't begin to have the expertise to answer a question like that. I do think if your support for that change is predicated on the idea that it's going to make lots of sick people a lot better physically, this ought to make you a little bit more hesitant about that belief. The second, the second question, I feel a lot more strongly about my answer, which is, and I talked about this a lot in Uncontrolled, I think the idea that we're going to do some experiment and we're going to be able to slam our fist down the table and say, now we've settled the issue, now we know the answer, is extremely unrealistic. I don't think there's any such experiment which is going to be able to settle policy debates once and for all. I think that, therefore, there's not a better experiment, I would argue, for here. What I'd argue is we should be embedding the capability to do lots of fast, cheap experiments in our distribution, in our execution of these kinds of programs, including Medicaid and similar programs. In other words, if we didn't have one experiment where we're trying to, tilt our heads and squint out of the corner of our eye to see what can we draw to this one experiment, which is the one we've done since the one 30 years ago, and instead we were looking at 85 experiments that were run last year across 50 different states, I think we would be able to draw much more reliable, kind of practical engineering conclusions about, gee, it looks like this version of this seems to work well because we see it replicated 9 times, and none of these experiments is perfect, but it just seems it happens over and over, and here's this surprising thing that we thought should work, and we can't figure out how to make it work, et cetera. That, to me, is how you make progress. It's lots and lots of fast, cheap experiments, not the one moonshot that's going to settle the debate.
Yeah, I think we have a lot of romance about randomized controlled trials like this because they remind us of science. It's like we got the Petri dish over here that has the, whatever, and over here we got the Petri dish that has a different thing, and that's science. So if we have a control group and an experimental group, we're going to find the truth. We're not going to be confused by – and I think one thing I think listeners can take from this conversation and related conversations is the elusiveness of truth, that it's much harder, as you point out in your book, Uncontrolled, and I think you do it very beautifully, in a world of what you call causal density, where there's lots of different things changing and happening at the same time, and there are a lot of unobservable differences between groups. You should lower your expectations.
Yeah, that's right, and I think it goes in a very specific way. In other words, I think that you really can find truth in the scientific sense. You really can find the right answer, the true answer to these questions about causality. It's just an experiment answers an extremely narrow question always. It's not, does Medicaid help or hurt? You don't answer. What your answer is, when I randomized people into this lottery in Oregon on these dates, what was the causal effect of being randomized in or out of that lottery? And the reason you heard me hedging all the time is I've learned the hard way. As soon as you step an inch off that platform to start to make more general, not seeming grandiose, but sort of seemingly direct implications of that, you run into the danger of fooling yourself into thinking your knowledge extends more broadly than it does. That's why you need lots and lots of experiments. You build this picture of knowledge by a pointillist painting, by having lots and lots and lots of experiments that get the answer in very narrow circumstances, but you can add those up to, really useful conclusions, I think.
My guest today has been Jim Manzi. Jim, thanks for being part of EconTalk.
Thanks very much.
This is EconTalk, part of the Library of Economics and Liberty. For more EconTalk, go to econtalk.org, where you can also comment on today's podcast and find links and readings related to today's conversation. The sound engineer for EconTalk is Rich Goyette. I'm your host, Russ Roberts. Thanks for listening. Talk to you on Monday.